Greetings mere mortals, my name is Sean Shooping and welcome to my lab. In the IT industry at the moment there's a huge push towards automation, but for the mere mortal just starting their automation journey it can get a little bit confusing. So in today's experiment I'm going to be playing with Ansible AWX, GitHub and Openstack, and I'm going to be automating some administrative tasks for a fictional company in the hopes of providing some sort of context or inspiration on how you can start automating the repetitive tasks of your day-to-day. So for the mere mortal just starting the automation journey, what does it actually mean? How do I start? What's actually involved and why should I care? So to answer all of these questions, let me create a scenario to put things into context. Let's pretend that I work for a company called devzero.edu. I teach an introduction to Linux class to about 50 students over 5 weeks. The students are split into 5 groups and each group attends 1 class per week. The main thing to note is that the groups aren't always the same size. To give the students a more realistic expectation of working with Linux, we provide access to 3 machines installed with different Linux distributions. And those machines are hosted inside of our Openstack cloud so that we don't have to deal with the pain of setting up and configuring virtual machines on our students' personal computers. That said, if we run the numbers real quick, if each student gets 3 machines, we need a total of 150 machines. Even with the smallest possible virtual machine, my tiny little Openstack cloud doesn't have the physical resources to accommodate 150 machines. The other problem is that not all the students get taught at the same time. So at any given moment, I'll have at least 105 virtual machines doing absolutely nothing. So to overcome this problem, what I'll do is that I'll create 45 machines instead, which is the largest group of students times the number of Linux distributions, and we'll just share the machines amongst the group of 50. Now this will create some challenges further down the line, but nothing that we can't solve. Okay, so now that we have some context, we now know that I need to go build out a whole bunch of virtual machines. I'll also need to manage user access to the machines. I'll need to manage access to the course material, and I'll actually need to manage the data that the students themselves are creating. So traditionally, to do all of this, what I would have done is something wholly uninteresting like create a golden image and then spun up multiples of that golden image. But instead, what I'm going to do is that I'm going to define our infrastructure as code. I'm going to push that code into a source control repository, and then I'll get AWX to read that code definition so that it can go ahead and build out the infrastructure for me. This way, if I forget to add something or want to modify an aspect of the deployment, all I really need to do is change a line or two in my code and then rerun the deployment task without having to worry about recreating the golden image. So to get started, I'm going to create a new code repository on GitHub. I'll leave a link in the description of this video to the repo, so feel free to copy it or just use it to follow along. The first bit of code I'll write is a basic Ansible playbook, and this is just to give some sort of context of what the code looks like and does from an Ansible perspective. So over here we can see that I'm using the Openstack server module. We'll set the machine state to present, give it a friendly name, and then just fill out all the required options relative to my Openstack. And then finally there's this meta key, which is a custom tag I'm going to add to the instance, and I'll use this in a later step to target specific jobs to specific machines of the same OS type. Now we can go ahead and save the file, commit the code changes to the project, and then push the code into GitHub. Next, we'll tell AWX how to retrieve the code from GitHub by creating a new project. We'll set the source to Git, and we'll just provide the URL to the repository. Now, we'll tell AWX how to authenticate to the Openstack project so that it will be able to build the infrastructure for us. We'll create a new credential, select Openstack as the credential type, provide a valid Openstack project, username, password, and the URL to Openstack's identity provider. After this, we can configure a new job template, give it a name and a description, and then select the AWX project we created earlier. And here we'll see that the playbook, which we pushed into the repository, is now available to use. Lastly, we'll select the Openstack credential to authenticate the task and then save and launch the template. Okay, so after the job completes, we can switch to the Openstack dashboard. And here we can see that AWX has built our first server for us. Now that we have one server, we can simply copy and paste the code and make some small changes to add an additional server. And after this, I'll just push the code into the repository, and then I'll just simply rerun the same job on AWX. And what you'll see is that AWX will read the latest code from GitHub, and if there's any changes to that code, it will only action those changes. Okay, so now that we've seen how to build infrastructure using a playbook, what we do notice is that there's a whole lot of repetition in the code. So instead of using an Ansible playbook to build the actual servers, I'm going to switch to an Ansible role. In the Ansible role, there's a little bit of a structure to it. We've got two different directories for tasks and variables. And inside each directory, we've got a playbook called main.yaml. If we look at the tasks, it's very similar to what we did in the playbook, except now that I'm declaring some variables. So when the role executes, it will look up the value of the variables in a dictionary called server_definitions and keep looping the task for every item in the dictionary. If we look at the variables, it only contains the parameters that are needed. All the parameters that don't change can be hard-coded on the task. So once again, I can just commit and push that code into the repository and then set up the required job template, which will create all the servers using the tasks and vars in the Ansible role. So now that we've built out all the virtual machines, we can actually get to automating the remaining administrative tasks inside of the VMs. But before we do that, we'll need an inventory so that AWX knows the IP addresses of all the servers so that it can log into them. Thankfully, we can get AWX to query OpenStack directly and pull back the IP addresses, host names, and tags associated with each instance, and then build out a dynamic inventory that's always up to date. So to do this, we'll create a new inventory, give it a name and a description, and then add the source. In this case, the source is OpenStack, and we'll use the same credentials that we used to build the servers. So quick tip that I picked up along the way, by default, AWX will use the public IP address of the instance and the instance unique ID in the inventory. By adding these two extra variables to the inventory source, we can make sure that the inventory uses the internal IP address, which is what I want to do, and then use the human readable friendly name of the instance. Now that we have an accurate and current inventory, we can finally configure AWX to do some of the administrative tasks inside of the VM. On an OpenStack image, after the VM is built, the username to log into it is the name of the distribution. So for CentOS, the username is CentOS. For Fedora, the username is Fedora, and so on. So to run administrative tasks inside of our VMs, we would need to have 3 different sets of credentials to achieve the same task. So to get around this, we can simply create a service account on all the machines, and after that, all future administrative tasks can be run on all the machines using the service account. So again, we'll be using code to automate this process for us. So we'll write a playbook which creates a group called wheel, ensures that users belonging to the wheel group are permitted to execute commands as root without a password using sudo. It creates the user service underscore Ansible and adds it to the wheel group, and then adds the SSH public key to the user's authorized key file. To run this playbook inside of the virtual machines, AWX will need to authenticate to log in. So this time we're going to create a credential and select machine as the credential type. In this example, I'll set the username to Ubuntu and provide the private key material which matches the public key used to build the VMs. I'll then just simply copy the credential and just change the username to CentOS and Fedora accordingly. Now what we can do is we can create 3 different job templates, one for each of our 3 Linux distributions. In this example, I've configured the job template to use the Ubuntu credential, and then if you recall at the beginning of the video, I mentioned I was going to add a custom tag to each instance using the meta key. I can now use that tag in the limit field, which will ensure that we are authenticating as Ubuntu to Ubuntu servers only. Otherwise, the task will fail on servers expecting the username CentOS or Fedora. After this, I'll simply create 2 more copies of the job template, making sure to set the credential and limit metadata flags to CentOS and Fedora accordingly. Now, instead of running each of these job templates separately, we can get a little bit more efficient by using one of my favorite features in AWX and run these 3 templates as part of a workflow. To build a workflow, we can click on the template tab as usual, and then we create a new workflow template. After we name and save the workflow, we're dropped into the workflow visualizer. We can now visually arrange how multiple tasks relate and lead into each other. So we'll create 3 forks, and on each node we'll attach the add service account template we created in the previous step. When this workflow runs, because the tasks are stacked in line, they'll actually run at the same time. So if you remember at the beginning of the video, I mentioned that sharing the servers amongst the group of 50 would create some challenges. So in the second week of the course, we started making modifications to the servers by installing and configuring Linux packages. So after the first group of students completes this exercise, the remaining groups have potentially nothing to do because the packages are already installed and configured on all the shared servers. So what we could probably do is that we could probably purge all those packages and try reset the configuration to a clean state, but I'm lazy. So at the end of the day, what I'll do is that I'll simply delete all the servers and then get AWX to recreate them for me. But what about the user data in each user's home folder? So to get around this, I'll simply place the user's home folders on a remote NFS share. So even though this server gets deleted, the user data is preserved and will just get plugged back in again by remounting it on the replacement server. So with this in mind, we can do this repeatedly as part of our workflow. So right after the service account tasks run, we'll add the manage NFS task and then link it to the previous tasks so that it only starts running after all prior tasks have completed successfully. After that, we'll run the Ansible role, which creates the 50 user accounts across all the servers. Now, seeing as though these 2 tasks run as the service account, we can start doing cool things in the playbook, like using conditionals. So if we look at the code real quick, in the NFS task, we'll use the apt package manager to install NFS client when Linux distribution is Debian or Ubuntu. We'll use the DNF package manager to install NFS utils CoreOS when the Linux distribution is Fedora. CentOS already has the NFS client package built in. We'll also need to relax SE Linux so that we're permitted to use NFS-based home directories when Linux distribution is CentOS or Fedora. Ubuntu doesn't seem to mind this behavior. And lastly, we'll mount the course material in read-only and mount the user homes in read-write on all of the servers. To verify that all tasks have completed successfully, I should be able to log into any of the servers as myself, and here we can see that I'm logged into a CentOS machine. And if I run a df-h here, we can see that my home folder is indeed mounted on a remote NFS share. If I go back a directory and run a list in the NFS mount, we can see all the other users' home folders there too. So in the background, I've gone ahead and created another workflow which deletes and recreates all the servers. And now that's all left to do is schedule the 2 workflows, which will run every day at 9 p.m. while I watch Netflix. So in the morning when I wake up, I can just make sure that everything ran successfully the night before, and this way I'll know that I'm ready to teach that day's class. So as we can see, with a little bit of forward thinking and a small amount of effort, I can completely offload boring and repetitive administrative tasks to a piece of software, giving me the ability to focus my time and energy on something more important and more exciting. So hopefully I've done justice to my introduction to automation with Ansible AWX, GitHub, and Openstack. And if you've enjoyed this video, give it a like. And if you like geeky videos like this one, please consider subscribing to my channel. But as always, thank you for watching, and I will see you in the next video.